Here illuminates that light. So when we turn the vent demo on, I want y'all to see we got two light bulbs on top. The one on the right is telling me that demonstration is energized at nominal voltage. The one on the left is representing a house. That's what. So we'll play with that for a little bit. Just kind of keep that in mind. So that's how that kind of works on the demo. But that is 7,200 volts on that top wire. It's the same voltage that most of our distribution zones. Some of it's 14,400. This one here is 7,200.
Before we start talking about conductors and things of that nature, what I like to do, because for a long time when I started out in line work, I was an apprentice and I understood line work, but I really didn't understand electricity. So I'm not an engineer by no means. I'm just a old lineman, I guess I can emphasize that. But here's the thing, the way I look at it, electricity is like an animal. As soon as it's created at the power generating plant, it's got one goal and one goal only, and it don't matter how it reaches that goal, it wants to go to ground. You say, what's ground? Is the ground a piece of wire? When I say ground, it wants to get in this ground we're standing on. It don't matter how it gets there. It can get there through, if it gets against that power pole. Wood, does it conduct electricity? Okay. Wires, does it conduct electricity? Yes. It don't matter how it gets there. Will our body conduct electricity? Yes. So that animal, it don't matter which way it gets there. Now, we've got ways we want it to get there. And this is something for a long time I didn't think about. These light bulbs we got right here, whether it be your TV, your washer, your dryer, your microwave, whatever. If you get one of these light bulbs that's clear, it's got two wires like this, if y'all have ever seen them, and a little squiggly wire ties it together. Well, that's a hot wire and a ground wire, and it's got a small wire tying it together. And it never dawned on me, I always thought you never put a hot and a ground together. We put a hot and a ground together on everything we use. But these people that's way smarter than me set that piece of equipment up to know what size wire to how, and the resistors and all this to put in there to make it work. Out here, if something gets on this line, there is none of that. So a controlled fault in that light bulb is what we want. An uncontrolled fault is what we're trying to stay away from. And just remember, we'll start off by showing you these wires. Some of these are, who knows what kind of wire that is? There you go. I don't mind. Hey, it ain't, take a guess.
Cable wire?
There you go, man, got it right. That's a cable wire. Is a cable wire a conductor? Can 7,200 volts come through a cable wire? Absolutely. Keep that in mind as we start talking about all this. We've got little phone wires, triplex, ACSR, all of it can carry electricity. So keep that in mind as we talk about all this.
When are you going to see wires or conductors on the ground, on the earth? When are you going to see that? During storms. That's pretty much what we're going to hammer on is storm maintenance. To me, that's the most dangerous part of our job and your job is storm maintenance, restoration, because people are doing what we're doing. We're back feeding. Right now we're back feeding this demonstration. Y'all see how that's stepping the voltage back up to 7,200 volts. Same thing with people. When power lines and trees fall on the power lines and tear us down, they fire the generators up and they're back feeding with a generator. That's the same thing we're doing now. We're back feeding. We just ain't got a generator. We're using that transformer as a back feed source. So you have conductors on the ground underneath the trees. So before we can start touching wires, there's several things we have to do. We have to ground the line down before we're allowed to touch it, and we're working on it, even de-energized. And that's grounding the lines down. Then y'all have grounds in y'all's trucks. Y'all do any grounding? Most of the time they send linemen out ahead of you and they ground the line down, and Kevin will hammer on that a little bit in a little bit. How we used to ground and how things need to be changed a little bit now, the way that's grounded.
Where's the best ground we've got on our system? Anybody know anything about power? What's the best ground? Neutral, that's right. Okay, so that neutral is this bottom wire. Your primary wire is up top, just like these. Your bottom wire is what we call a neutral, or the ground. That neutral reason is so much better. If you follow this line out, if it goes 10 miles back to the substation, Every pole's got a pole ground that goes down and connects to a ground rod that's in the ground. Every one of them's attached to that neutral. When it gets back to that substation, if you took and magically removed all the rock and everything in that substation, there's one big huge ground grid underneath the ground in there, and everything's tied to that. So that's the best ground on our system. So when Russell's finna show you how to make it safe to touch a wire on the ground, you'll understand why he's connecting it to that bottom wire, because that is our best ground.
All right, so let's just pretend a tree fell right through this span of wire and tore it down to the ground. So what normally happens, you can see there's no light bulbs lit up. So the linemen usually come out there and they start isolating. They start getting air on things to get people back on. So if this wire was tore down, I would come up to this power pole right here and open the switch, which would isolate this section of wire, and I'd call dispatch and hit the line back up. Now we got all these consumers on this side of wires back energized. All these consumers are de-energized. Y'all see that? All right. To work on this wire, we got to isolate the line. So we got some air there. As you can see right here, I've isolated this conductor. There's an air gap all the way around this conductor. Nowhere is it electrically connected to a line. Y'all see how that works? That's the first thing we're going to do. The second thing we're going to do, we're going to check for voltage. I'll show you how this thing works. When you put it on an energized wire, see how that flashing? That's telling me that it is energized. We got some new ones that make a bunch of noise and sirens and lights. This is an antique. So you put it on this side right here.